What's up, pre-calculus students, mostly period 4? Might actually do this for all the periods just to give you guys a similar experience. We are going to do the practice problems before the quiz. You're going to take the quiz. We have a test next class. Honestly, if I were to focus on practice problems, I'd probably work on the tangent problems more because I don't think I did a good job teaching it. But hopefully you watch Miss Salas's video and you're good. So we'll get to those. Hopefully you're doing the problems first and then you're checking your answers with me here. All right, here we go. We have our free response problem. This will be worth like 6 questions on your test. It's exactly how it's going to look on your AP test. We got a 10 centimeter long hand. That's the hour hand. That's 10 centimeters. That's like the radius. That's going to be my amplitude. I'll worry about if it's positive or negative. So maybe let's not say it's A. Let's say the amplitude is 10. Center of the clock face is 200 centimeters from the floor. So that's going to be my vertical shift. That's going to adjust my midline. So that's going to be D. Hand is pointing directly up at 0 hours. So that'll have the maximum height. So if I have the center 200 centimeters and then the amplitude of 10, I'm going to go up to 210, and this is where I start. I have a midline of 200, and I'll have a minimum of 190. That's applying the amplitude. The next time the hour hand points directly up is in 12 hours. Okay, that makes sense. There's no frequency. There's no like period calculation we have to do. The period is 12 hours. After 12 hours, we will complete 1 cycle. That's what we have to pay attention to. If there were some amounts of cycles over amounts of time, period is the amount of time for 1 second. So just remember that for your quiz because you have a couple things. I think we do it on the next one. The period is like the time it takes to complete 1 cycle. So divide, simplified, so it's a unit rate. All right, we got everything we need. If the period is 12 hours, and if I start at 0 and I will get to the end, be careful on your quiz. We might not have all of these points here, so don't go to the last point and say that's 12. Like pay attention to the fact that you have to return to where you came from. So that's 12. If we want to step it out, you take your period and divide it by 4. You get 3 hours each step. If you want to just like start halving, you could do that too. That's easy enough. Okay. So now I have the points for my F, G, J, K, P. F is going to be 0 to 10. G is going to be 3, 200. J is going to be 6, 190. K is going to be 9, 200. P is going to be 12, 210. All right, if I were to use sine, let's pay attention to what trig function they're asking you to use. Typically, at least of what we've seen, they switch it up from what we would normally use. Like I would use cosine because we're starting at a max, but they want you to use sine. So I can either go off the point at G or K. Understand I'm taking my parent function, I'm going to be shifting it to the right. If I go off of G, let's find B really quickly. B is 2 pi over the period. 2 pi over the period, which was 12 hours. B is going to be pi over 6. Again, you found your period is 12 hours. This is my step, not my period. Okay, so if I were to go off of G, I would use a vertically reflected graph, a negative A. I would use pi over 6 regardless. I would use 200 regardless. If I go off of G, I'd have a -3. If I want to go off of K, or if I want to go off of a point from the past, I'd use the regular graph of the parent function of sine. I would shift over 9, not 6, 9. So A would be positive, this would be 9, and this would be your answer. J and K, T1, T2, between J and K, what's happening? Well, H has positive values. This is like something where it's like we haven't seen many negative values on the next example. On the next page, we have some negative values, but like this question is not about the rates of change being positive and increasing. Um, it's about just the values of H being positive and increasing or decreasing negative. And so like really right off the bat, H is not negative. Again, it's not the rate of change. It's just the values. The values of H are positive. Cool. Between J and K, they are positive and increasing. If it was, what's the following is true about the rate of change of H? You would say H's rate of change is positive and increasing. That means we are increasing concave up if we're talking about rates of change. But this question too is describe how the rate of change is changing. We are concave up, so this is a rate of change that is increasing. Cool. All right, another question. This one has some frequency, which means we have to adjust our period. We got a water wheel. During peak operating hours, the wheel spins at a rate of 8 revolutions per minute. Okay, it's very important to understand the period being the time it takes to complete one cycle. It takes 1 minute to complete 8 cycles. What does that mean? Your period is 1/8. That means B, which is 2 pi over my period, would be 16 pi. Okay? 1/8 divided by 4 would be 1/32nd to step it out if you wanted to graph it. You don't need to graph it. Let's just go off of what we have for my equation. The radius of the wheel is 8 feet, so this will be the amplitude. I'm going to go to a maximum 8 feet higher than the midline. I'll go to a minimum 8 feet below the midline, so A is going to be positive or negative 8. The amplitude is 8. Center of the wheel is 6 feet above sea level, so that's my midline adjusted. So we at 6. That means we're going to go up to 14. We're going to go down to -2. Okay, we kind of tried to do this with the boat, getting some negative values. If I asked you for the max and min, boom, 14 and -2. We are below sea level of 0. Not super important, but maybe like if I asked you what's going on between this like very small interval, now we can have some negative heights that are increasing or decreasing. Like if your point is down here, you'd have a negative height that could be decreasing or increasing. Okay, so let's use sine and cosine. I'm starting at my midline. I might want to just sketch this graph really quickly just so I'm not making any mistakes and you're understanding what's going on. We'll just assume, probably just in the way whoever wrote this problem up wrote it, didn't like talk about how point P starts like immediately at the midline at time 0. Let's just go ahead and assume that. Goes up to 14 down to -2. It takes an 1/8 of a minute to complete one cycle. You start at the midline. As the wheel rotates counterclockwise, we would go to our maximum, back to our midpoint, minimum here. If I asked you for points, I would take this maybe divided by 4, 1/32. 2/32, or half of my period, 3/32. Cool. So maybe if you're asked for points, this would be a way to find that. Amplitude, again, is 8. If I were to use sine, easy, because we're starting here. So I got sine, I got B. 16 pi is not going to change. I'm not doing any shifting to the right or to the left. I'm starting kind of at the uh, at the midline. Sine starts at the midline. Sine of 0 is 0. And then d is 6. If I were to use cosine, however, you could go off of either this point or this point. I probably would go off of the point at 1/32 because the cosine of 0 is 1. If you were to shift your parent function right 1/32, up 6, boom, you would be at this point with the amplitude adjustment. So you don't have to change a to be a negative. A would be positive 8 cosine. I still get b, but I do need to shift my parent function right a 32nd. So I'm going to subtract a 32nd and add 6. You could always check your values by plugging in things. Like if I plug in 1/32, I got the cosine of 0, which is 1, times 8, which is 8, plus 6 is 14. That's that point there. If I plug in a 16th, I'm going to get the cosine of pi over 2, which is 0, which means that's going to get zeroed out, plus 6. Like everything can be checked off, and you're good. All right, now let's get into tangent graphs, which I didn't do a good job of. Like in terms of like sketching, if you asked to sketch. Now, most of the questions that you're going to have on your test just refer to like, here's your equation, what's your period? Or here's your equation, where are your vertical asymptotes? Just to go over graphing the parent function one more time. Tangent of 0 is 0. You got to remember this. You have to have the unit circle in your brain and think about the OA, y over x, y is 0, x is 1, 0 over 1. But if I go to pi over 2, the tangent of pi over 2 is undefined. Okay, so this is kind of how we're going to help ourselves start. That tangent is 0 at the horizontals, and it's undefined at the verticals. Undefined at the verticals, 0 at the horizontals. The graph of tangent is positive in the first quadrant, then negative in the second quadrant, positive in the third quadrant, negative in the fourth quadrant, which is why my period is pi. I repeat the graph of tangent in pi because I just go around half the circle. I get positives, negatives. Once I go into the third quadrant, we're back to positives, negatives. Period is pi. Now, that means if you have a horizontal dilation, you need to adjust your period by dividing by b. But it's pi divided by b, not sine and cosine, which is 2 pi. Takes the entire circle to start repeating values, 2 pi over b. So here, b is 2, period is pi over 2. I would take all of these x values, divide them by 2 to have the graph of this 3 tangent 2x plus 5. So like if you wanted to, you'd say my period's pi over 2. If you wanted to sketch this graph quickly, you would say, okay, 0. I'm not shifting things to the right or left. I'm still starting at 0. This would be pi over 2. Okay, the middle of the tangent graph is where we start repeating. So then this would be pi, and then to find a step, you just divide by 2 versus dividing by 4. You don't want to go all the way to the end because that's 2 periods of tangent. The pi over 2 is the middle. Divide that by 2. That gives you your location of your vertical asymptote. That means 3 pi over 4 is a location of your vertical asymptote. Here's a good way to kind of like be able to write the locations of your vertical asymptotes. Ready? You got your vertical asymptotes of this parent function. Vertical asymptotes of my parent function are all of my pi over 2's with multiples of pi because I start repeating after pi. So it's like all of my verticals would be listed off as that. Horizontal dilation of 2. Take all of this and divide it by 2. You'll get your vertical asymptotes of this. What does that look like? Well, for this equation, take this and divide it by 2. It becomes pi over 4. take this divided by 2, it becomes pi over 2n. Pi over 4 plus pi over 2n. So let's think about that. That's 2 pi over 4s. I got pi over 4. I got 3 pi over 4. I'd have 5 pi over 4. So start with your parent function. And again, like you can go back to unit 5 with understanding dilations, and you could just take all of these x values and divide them by 2, which will take your vertical asymptote locations, divide them by 2. All these adjustments can be done. If this was tangent x over 2, then the period would be pi over a half, which would be 2 pi. Okay, like pi over b. Now, if I'm dividing by 2, that's a horizontal dilation by a factor of 2. You take all these x values, multiply by 2, and you'd get like pi, 2 pi, 3 pi, 4 pi. You take all of this information, multiply by 2, you get pi plus 2 pi n for your vertical asymptotes. These are all the different ideas for tangent. But usually you don't have to graph tangent. You just kind of have to understand the equation. The A doesn't matter for us in terms of like amplitude. It all matters about direction that we travel. If I have the negative tangent graph, it would just go in the opposite direction. The 5 just shifts the midpoint. This would be up 5. That's going to be your like D. So this is like all understanding of transformations. So like here's 2, here's the graph. Tell me about the information. What's the period? When do we start repeating myself? We start repeating every 0.25. That's a fourth. What's B? Well, if the period of tangent is pi over b, then b is going to be pi over the period of 1/4. 4 pi is going to be your b value. Your graph is going up, a is positive. That is all you have to do for this situation. It's not like crazy. For example, here I said like plus or minus. Well, my graph is a vertical reflection of tangent. I have a minus. I see my period. I start repeating myself every 4. My period is 4. Well, b for tangent is pi over the period. So b is pi over 4, okay? My parent function starts at a 0. Like the tangent of 0 is 0. I'm shifting my starting point either to the right 3 up 5 or to the right 7 up 5. It doesn't matter. You can go x minus 3 or x minus 7, and it's good because of the whole repetition of things. I'm shifting my y's up 5. This would be the equation for p of x. Not crazy difficult tangent. It's not as intense because we don't have to worry about the amplitude. We just have to worry about horizontal shifting, vertical shifting, then the period being adjusted to be pi. Okay, hopefully we're all good with this. You ready to start your quiz, which is kind of long to do, so make sure you're giving yourself plenty of time to do it. And then for period 4, I'm going to grade your quizzes on Monday with my calculus students probably. You can get it back Monday afternoon. I will post the answers to your quiz 7-3 Monday afternoon. Have a good weekend. Mr. Messner, out.